I will be explaining this proposition in this video. Here you can see the statement. Let C be a countable subset of the open interval a comma b. That is, from this open interval a comma b, you are taking a countable subset. And that countable subset is denoted as C. Is that clear? Then there is an increasing function on a comma b. If C be the countable subset of a comma open interval a comma b means there will be an increasing function. Where you will have this increasing function, you can find this increasing function on this interval. That is, that increasing function you have, no, that is continuous only at points on this. That increasing function is continuous at a point. That point is present on this a comma open interval a comma b difference C. That is what we have to prove. Let me repeat what you are going to do in this. Do in the proof of this theorem is, first you have to define a function, that is f. Okay, and you have to prove that f is what? Increasing function. That is what the first thing you will do in the proof. And then what you will do is, you will take a point from this. Okay, the point will be x0. And you will say this function f, you choose an increasing function, no, f, that function. Did I tell you that the increasing function is f? Okay, I will tell you that increasing function you are going to take from this interval is f, okay, and also you will take a point from this, that is x0. What you will say is that f, increasing function f, is continuous at this point, x0 present in this. This is what we have to prove. Can you understand my question? Okay, so here let's start proving this proposition. Here you can see the proof. Look at mine. Look at these notes. If you look at this, really you will feel confused because it is not in a way to tempt you to study. Okay, it is not like that, right? So that is why I wrote it in another one paper, so that that helps you to feel easy. Even when you look at the proof itself, you will get a confidence that yes, I can learn this proof because it is very easy. That mentality will come. Okay, then the learning will become easy. Okay, here first what you have to do is, you have to take a subset. Okay, what you are having in the statement, C be the countable subset of open interval a comma b, right? So first you have to take the subsets. Okay, let Qn n equal to 1 to infinitive is a countable collection of C. Okay, that is what you are taking this. Let Qn n equal to 1 to infinitive is what? The countable collection of script C. Now define, you are defining a function, right? First you have to define the function, and you will say that function is increasing, and then you will take a point x0 from where? I will show you. You will take a point from this, what? This. And you will say that function f is increasing at the point x0 in that a comma b, open interval a comma b difference C. That is what we have to prove. Okay, let's see. First you have to define a function, right? First you have to define it. F of x equal to summation. In your note you will have like this, n such that, see, n such that Q1 less than, it is not necessary to put n such that, all those stuffs. Okay, it is enough to write like this. F of x equal to summation Qn less than or equal to x 1 by n. For this x you have, no, that x lies between a and b, open interval a comma b, and n be a natural number. Here you are using n, right? This n is a natural number. So you are defining a function like this. F of x equal to summation qn less than or equal to x 1 by 2 power n, where x lies between a and b and n is a natural number. This is how you are defining. So since you know that summation 1 by 2 power n is a series, okay, and in a small classes, that is in first year MSc, you will learn that summation 1 by 2 power n is a convergent series. So you are using that. Since the series summation n equal to 1 to infinity 1 by 2 power n is convergent, since this is convergent, okay, since this is convergent, you can say this is finite. Okay, the series is what? Finite. Because this is convergent, this will also convergent. Okay, so that is why you are saying summation, if this is convergent, you are saying this is what? Finite. So from this you have said f of x is defined. Now what you are going to prove is this f is increasing. To prove that, what you are doing is, if a, you are taking two elements from this a, between this a and b, between this interval you are taking two things, that is u and v. That is what you come to know from this line. A less than u less than v less than b. These are the 2 points present inside this interval a comma b. Now then you are finding f of v minus f of u. Why you are finding all these things? To say f is increasing. Okay. So f of v minus f of u is equal to, you have, if f of x means, you will write in this format. Here f of x means, here you will put x. If f of v means, here you will put v. That is the only difference. If f of u means, the place of x you put u. So that is what you are writing here. Summation qn less than or equal to v 1 by 2 power n minus summation qn less than or equal to u 1 by 2 power n. Now what you are doing is, you are combining these two. Okay, so when you combining these two summation, and you are writing this. Okay, so how you can write this summation? You are writing q1 lies between u and v. Okay, that is what you are writing. Now one thing you have to note here you are putting less than. In putting less than, there is no any confusion. Both side you are putting less than. But here you are having equal to, but here you are not having equal to. Why? Because if you look at this, you are subtracting. No, you are subtracting. So u is not going to include here. Okay, so that is why here you are not putting equal to, because this is subtraction. You are subtracting this from this, so u will not present here. That is why u less than qn less than or equal to v. Okay, qn lies between u and v. Then put 1 by 2 power n. Now this value will be greater than or equal to 0. I have no proper explanation for why you are saying this value is greater than or equal to 0. Similarly, in another, you will have another one part also. Here, in this place, the value of this you will put greater than or equal to 1 by 2 power k. I am also not having proper understanding on these two. In these two things, I have no proper idea. Okay, so here, for this you are putting greater than or equal to 0. You got f of v minus f of u greater than or equal to 0. So from this you can write what? F of v greater than or equal to f of u. That is what you get there. No, you are bringing this term to this side so that you will get this. So from this you are writing first u term, f of u less than, the same thing you are writing like this. You can write like this, right? F of u less than or equal to this. If u less than v, right? U is less than v, no? So that is what you are writing. You are getting this if u less than v. From this you can say u is less than v. U is smaller. U is smaller. V is bigger. So the image of this is f of u. It's f of v. So what you got? F of u also less than or equal to f of v. It means it is increasing, right? This is small. The value comes after this is bigger. So if another one value is coming, then that will be bigger than this. So it is keep on increasing. So that is why f of u less than or equal to f of b if u less than b. Here you may commit mistake in this. You may write f of u minus f of b is equal to, like that you may write. Okay, so you should not commit that mistake. What is that? F of v minus f of u. Here you have to write u v lies between a b. When you then here what you have to write is f of v minus f of u you find. Okay, don't write mistakenly f of u minus f of v. They may arise confusions. So f is increasing, you proved. Now what you have to do, you have to take a point x naught. Oh, sorry. Now what you are doing is you are saying this f is, in our proof we have to say f is continuous. Okay, so before that you are saying f is not continuous. F is not discontinuous. Oh my god, what I am blabbering. Okay, you proved f is increasing. Now what you are going to prove is at the point f is on C, okay, on this collection f is discontinuous. That is what we are going to prove. Now in this point our intention is to say a comma b different. In this point you have to prove f is what? Continuous. So before that you are saying at C f is not continuous. That is what you are saying from here. You are taking x naught equal to q k belongs to C. You are taking a point from C, that is x naught from C, and you are going to say this x naught is f is discontinuous on C. Okay, let's see how. You are finding f of x naught minus f of x value. The same process what you have done here, the same thing you are doing here also. Okay, here you are subtracting, no, that is why here you are not putting less than or equal to, only putting less than or equal to x naught, that is equal to q1. Okay, now from this you are writing greater than or equal to 1 by 2 power k for all x less than x naught. This is important. X is less than x naught. Okay, you are getting this value. I'm not aware of how you are saying this from this step. Okay, so after bringing this you can say f is discontinuous because you are getting greater than or equal to, no, in the continuous definition you have to get less than or equal to, then you can say it is continuous. You are getting greater than or equal to, so you are saying f is discontinuous on what? C. Okay, now we are going to prove f is continuous on this point. This is what they are asking in the question. Can you see that? No. Okay, now you are going to say f is continuous at this. Okay, for that you are taking a point from this, that is x naught, and you will say f is continuous at this point x naught. Okay, so for that what you are doing is, then there is an open interval I. You are taking an open interval I, and within this open interval I you are having a point x naught for which Qn does not belongs to I. And there is a condition, Qn does not belongs to this interval I. Okay, where k is lies between 1 and n. Okay, so now we get from this, we get mod f of x minus f of x naught less than 1 by 2 power. And if there is a detailed explanation, from 1 we get, there is 1. Wait a minute. Here I did not mark anything as equation number 1, but here you are writing from equation 1 we get. Here is a confusion, right? Yeah, I think equation number 1 is this. This might be equation number 1. So you get f of x minus f of x naught less than 1 by 2 power n. That is, when you find f of x minus f of x naught, Okay, you are going to get less than 1 by 2 power n. If you get less than means for all this x naught belongs to I. Okay, if you are getting a less than means you can say f is continuous at this x naught. Okay, that is what they are saying, f is continuous at x naught. Therefore you have proved what they are asked us to prove. Can you understand this? Actually this is very easy. First you have to take a collection and then you are defining a function f like this, and you are first proving f is defined. Okay, and then you are proving f is increasing. To prove f is increasing, you are if you are considering this and you are finding f of b minus f of u, and from there you will get f is increasing, and then our intention is to say f is discontinuous on C. To say that you are taking a point x naught equal to the value of x naught is equal to qk that belongs to C. That is how you are taking. Your intention is what? To say this x naught f is discontinuous on C. So to prove that you are finding f of x naught minus f of x. You will get this. So finally you got this also, because greater than or equal to means it is not satisfying the definition of continuous, so you are saying it is discontinuous. Now you are taking a point x naught from here and you are going to find f of x minus x, f of x naught. Taking an open interval, and in this open interval you are having x naught for which qn does not belongs to I, for you are taking this condition. Now what you are doing is you are finding f of x minus f of x naught. Modulus of f of x minus f of x naught, you are going to get the value less than 1 by 2 power n. Therefore this x naught belongs to I. So you are getting less than now, so you can say f is continuous at x naught. So you have proved it. F is continuous only at the point of this. To say this only at the point, only you are finding in between that f is discontinuous on C. Okay, that is the reason behind finding this. So I hope you can understand this. Thank you.